This video is about equivalent fractions. So finding another fraction that's worth exactly the same amount as the given fraction, but has a different size piece. So in other words, has, in this case, more pieces in the whole. So this one is equivalent, this video is equivalent fractions with fewer pieces in the whole, and we're hoping to have more pieces in the whole. So we're going to use an area model for this. I really like an area model for fractions in general, right? Because I think it's nice and easy to draw fractions, and it can be very helpful to have that visualization of what a fraction is. So for two fractions to be equivalent when we're talking about an area model, they must cover exactly the same amount of area. Equivalent means that they're worth the same amount. So in a non-area example, 1/4, 5 dimes, 25 pennies, they're all equivalent, and that is not true. That should say 5 nickels or 25 pennies. These are all equivalent. So here's an area model showing a half. So this orange or yellow area is a half. Then this green area is showing 5/10. So notice I broke this up into 10 equal parts, and then I shaded 5 of them. The two holes, the two rectangles, are exactly the same, and they have shaded in the same amount. So this area model shows that 1/2 and 5/10 are equivalent because they've shaded the same amount of the hole. And I drew them so that the holes were the same size, so it was much easier for me to see. So let's find some more 1/2 equivalents. Now, some of these you might just be able to rattle right off your head. So let's take that knowledge that we already have and figure out how we could use a drawing to get those other 1/2 equivalents. So we'll start by drawing 1/2. So I drew 3 different boxes that show 1/2. And then in each of those boxes, I'm going to split them up into new pieces, remembering that those pieces need to be equal size pieces. And I'm going to do that, but I'm not going to change the shading. So I know the shaded amount is going to be the same. So if you notice in the red, I put 2 boxes, breaking it into equal parts, 2 lines. In the green one, I put in 3 lines, and then in the blue one, I put in 5 lines. And again, equal size pieces in each box, didn't change the amount of shading. So how would we describe what these are? Well, we're counting. So this is going to be, the red one is going to be 3, 6. So I have 1, 2, 3 pieces that are shaded. I have 1, 2, 3, 4, 5, 6 in the whole. If I look at the green, I have 1, 2, 3, 4 that are shaded. 1, 2, 3, 4, 5, 6, 7, 8 in the whole. So there's my 4 eighths. And then if I switch over to my blue one, I have 1, 2, 3, 4, 5, 6 that are shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in the whole. So that represents 6/12. So let's try another one. So let's do 2/3. So pause this video, try it on your own. Do it with the drawings. Try to figure out how drawings can be helpful when we are finding equivalent fractions. Okay, so this is what I got. So if you notice, if you look at just the vertical lines, like on this purple one, here's my 2/3. I have 3 pieces in the whole, and then I have 2 pieces that are shaded. And then I kept that same shape for all 5 of these rectangles. And then I drew horizontal lines to split them up. So now I can see that each of these rectangles are 1, the same size, and 2, have the same amount shaded. So now all I need to do is describe what each of those fractions are, and that will show that they are equivalent to 2/3. So I have 2/3, 4/6, 6/9, 8/12, and 10/15. And there are more. There are tons and tons and tons more, but these are a few. Okay, drawings can be very helpful when working with fractions. Equal area means equal value, assuming that the wholes are the same size. Equal value means equivalent fractions. So we can use drawings to help us come up with equivalent fractions.